Now let's look at testing. So here once again we are continuing with our dummy variable example where our model is given by this function and we want to test whether this model is significant or not. So overall significance will be given by beta sub 1 equal to beta sub 2 equal to 0. The alternate is that at least one slope coefficient is not equal to 0, which will make the regression significant. And let's assume 5% level of significance. So the procedure follows the same logic as we have done previously from this point onwards. So there are those four assumptions, LINE, okay, and then the overall test is MSR divided by MSE. And we have that from our output, MSR over MSE, or it is this F that we have already in the table, in the regression table. So numerator degrees of freedom is the regression degrees of freedom, and if you copy that one down, you'll get the degrees of freedom for the denominator, which is the error degrees of freedom. Then the F table value is F dot INV dot RT of 5% and the 2 degrees of freedoms. The p-value, we can get the p-value from the ANOVA table for regression, or we can set up the fdist.rt of the f stat and the 2 degrees of freedoms. So then we can say that the regression is significant because we are going to reject the null hypothesis, because f stat is greater than f table, p-value is less than 5%. Okay? So then we can provide an interpretation that we have sufficient evidence to conclude that the regression is significant, and the probability that this conclusion is wrong is 0.43%. Having determined that the overall regression is significant, then we can test for individual significance. So we have two slope coefficients, so beta sub 1, then beta sub 2, and we'll get the t-stat values from the regression output. From here we can calculate the t-stat by dividing the standard error into the coefficient, but we'll just get it from the output right there. Okay, and the t-table value is t dot inv dot 2t, okay, which is 5%, and denominator degrees of freedom is the MSE degrees of freedom which we want for the t-table. Okay. Now the t-table is same for both tests. I'll put the border back. The p-value, we can get the p-value from the output, which is what I'm going to do, so which is quicker. So we'll make that into a percentage. So the conclusion is reject H sub 0 for the first one, but the second one is do not reject. If you reject it, the second one, the probability of type 1 error is 65.6%, way too high. So that means whether there is fireplace or not is not a significant factor in determining the assessed price of the house.